Get him!
Jacob, you got me?
There we go. Just going to be a popcorn parade in here.
It is. Can I make it?
Yeah.
Nice. Well, it smells so good that.
It's cheap. It smells amazing. If you don't get the stuff that's overly processed in butters, it's actually incredibly healthy for you. So, go for it.
But it don't taste as good if it's not.
Now, if you get kettle corn, on the other hand, then we need to fight. Because kettle corn is trash. Yeah, I went there. It's just too sweet. Like, sweet plus popcorn, unless it's covered in chocolate or caramel, doesn't sit right with me. Yeah. Is anyone still rolling? Okay. Okay, a little update on timing then, while we're waiting for the last one or two to finish. Today, finish 5.5 for sure, get into 5.6, maybe even finish it. Because 5.6 is, if I remember right, a whopping 4 slides. It's basically what we already know, it's just now there's a term for it. And then tomorrow, I think we'll have enough for 5.7. Can't remember if 5.7 is the models or if it's the binomial expansion. What is it?
I don't know. I can take a look.
Binomial theorem. If y'all are distraction free, that should actually be a one-day thing. Quiz on Friday. 5.8 on 5.8 on Monday. And then we actually start something that I have to make the notes this weekend. Oops. Crap, I gotta do work now. You are the first Algebra 2 class that we're moving rational functions to Algebra 2 instead of Algebra 1. So I don't have those notes. I need to make those notes. Crap. So we'll do that next week. It's not difficult, and especially coming on the heels of polynomials, it should be pretty quick. I don't expect we'll be in that chapter. It's not chapter 6. We're actually going to jump ahead. I think it's chapter 8 or 9. We're going to do that, then go to 6. Just because it fits so well after polynomials. We're getting there. Ain't much longer. I didn't show you split term factoring for polynomials yet, did I? Where you split the negative 19x?
No, yeah.
Okay, never mind then. Won't do it. Instead, I'll say possible real and rational zeros. Because this thing is a cubic, I've got 3 possible real zeros. Ta-da! The possible rational zeros are all the factors of 6 over all the factors of 3. So plus or minus 1, 2, 3, and 6 all over 1. And then 1 over 3, 2 over 3. 3 over 3 I don't need, already got it. 6 over 3, don't need, already got it. So there we go. Now the question is just which ones are actually the zeros. And we did that by gazing into our crystal ball and saying, I feel oh so lucky about what? 3? Okay. We feel good about 3. Wow, you're really good at this guessing thing. Okay. And then say, I feel really good about what? -2. And then say, I feel really good about what? -2 again?
Sorry.
Okay. Because that can happen. You can have a 0 pop up more than once. And then because I divided my 0 by 3, I also need to divide this by 3. Which means my actual zeros are, my solutions are -2, -1/3, 3. Ta-da! So, do you have your possible real zeros? Do you have your possible rational zeros? Do you have, I'm going to say, all 3 of your solutions, the work to back it up, and then our floater for, I missed a negative here. I didn't put the plus or minus here. I continued and I wrote 3/3 and 6/3 here and just didn't realize that I can reduce those and they're already up there. That kind of stuff. So the floater for the facepalm.
What's the possible real zeros?
The degree of the function. Like, it's a cubic, so I might have 3 real zeros. Now, I can narrow that down, but that's the most I could ever have. I can't have 5 real zeros for a cubic. Right? It's like me asking you what, I don't know, when was your senior free block?
Tuesday.
Y'all ain't seniors. So, well, 1.
Yeah, man.
Okay, are you actually a senior? Because whenever our foreign exchange students come over, even if they're 15 years old, they call them seniors. Yeah.
Why?
I don't know. So how much does that suck when you're like 15-year-old foreign exchange student and you get tossed into, oh, I don't know, pre-calc and chemistry and like government and like you get thrown in all the senior classes when you're only a sophomore? It happens. I don't know. How many experience counters do you have? How old are you?
17.
Okay, that's like junior, senior. Yeah. So, all right. I am curious for purely personal reasons. Who in here has the summer birthday? The summer birthday, because summer birthday kids can either go a year late or a year early. No, that's in the school year. No.
It's like the first day.
So, are you the oldest of the class or are you the youngest of the class?
August 27th, 2004.
Well, that's still in the school year, though. Like, that's okay. I'm talking about the kids who are like June. Okay? So are you one of the oldest of the class or the youngest of the class? Right? Because my boy is June 25th. So he'll be 5 this coming summer. I don't want to put him in kindergarten. He ain't ready. He's my kid. He ain't mature enough. So we're going to probably hold him back a year. So then he's also only 1 year above his brother so that they are in school together longer. But I'm just curious, like where the summer babies are. All right. Homework. No one asked that I remember. And more importantly, if you goofed anything in the homework, I bet it was something small like, oops, I used the plus b squared instead of the minus b squared. It was the, oops, if I square 2 square root of 3, that's actually 12, not 6. So, talk to me. Homework. Anything get weird on us? Nothing? Were you cool with this stuff? Like, I can give you any two complex or compound roots and say, make me a polynomial. Are you sure? What if we chose something with all prime numbers? Like, even better. What if I did that? Can you make the quartic polynomial that has those as zeros? Find a spot. Find a spot somewhere in the paper. Okay. We're still going to do that Descartes' law of signs. I have not forgotten about that example. It's very easy, but I've not forgotten about it. But if you got any other room, like on this page where we were, what was it, number... If you can do this one, you can do any of them. So yeah, if you can do this one, this is the last one. Okay. Now you guys use the cheater. I'm gonna take the long route, just to prove a point. I'm doing the long way just to prove a point. You keep going. Oh, wait, I can't have that there. Ah, that's okay. It'll be ugly. Oh, that's big. So that's negative 175 plus 9 is negative 166.
Oh, I didn't see that.
Okay, yeah. I know that you can multiply quadratics. You've shown that. Can you get to the quadratics? Like, whether you're going to multiply longhand like this, or say, screw that noise, and x squared minus 2ax plus a squared minus b squared times x squared minus 2ax plus a squared plus b squared. If I do that instead, 3, 3, 5 root of 7. Square root of 2, square root of 2, 11. Look at how much that saves. No, it's a plus b I. B is the coefficient of I. Because if you put an I in there, now you're going to end up with an extra I squared, and it's going to change the sign again. If I use that orange-yellow line, I'm able to go straight here. Look at how much work you save. And then God, that was so stupid. What's that? 600, 720, 738. Plus 320, 332. Gross. 1660. 1660 plus 320 is 1980 plus 12 is 1992. It's 300. 22. Oh, that's fun. Plus 120. 2342. It's 18. 2360? That's a big old question mark right there. That's a big old question mark. Yeah. I completely missed the place value. That's why. Say it again. Okay, I'm going to stop right there. This is not typical Algebra 2. Like, if you saw this on an Algebra 2 test, if you saw this on an ACT, this would be at the beyond pre-calc level in terms of complexity, simply because it was a square root of 2 instead of a square root of 11. Y'all are really good. You've been doing very good. Is there a dumb?
I just have a question.
Yes.
So, for the first line of the red, the x squared minus
Roger that.
2 squared. So, but when you do, I'm looking. Never mind.
Great talk. Yes?
How do you combine? I'm looking at like in second.
Okay. That's where we're going. Okay. Then, am I able to combine a -6 and a -2 squared root of 2? They're not like terms, right? But they are still both coefficients of x cubed. This is also something that you probably wouldn't do until after chapter 6 when we review radicals. But the official answer for this, x to the 4th minus 6 plus 2 root of 2 x cubes. Like that. Plus, what's that, a -43? -43 plus 12 root of 2 x squareds. Plus 166 and 123. The rational parts go together, the irrational part stays off to the side. Plus, negative 738 plus 332 square root of 2 x minus 2418. Purely because of that square root of 2. This would be the kind of problem that I would just, I don't know, send you on remind on a Saturday afternoon and say, first one to show me the full answer gets Pop-Tart. Not worth it. First one to show me a full answer gets Dairy Queen lunch. Okay. This is not Algebra 2 level. Now, this is Algebra 2 skills, but putting it all together in one problem, this is like the challenge problems at the very end of the section. I would never do this to you. I just pulled some numbers out, tossed them up there, and said, let's see what happens. Okay. Oh, God, no. No, if this was on a test, I screwed up so bad. No. But can you follow the process? Right? What I want to make very, very clear to you, though, what I'm trying to show off is all this and all this that entire middle of the board doesn't need to be there. Because if I'm using those cheaters, it just knows that this is going to happen. And it can go straight there. Okay? I want you to see the benefit. Like in physical real estate, look at the benefit of using the cheaters. How much of the board am I able to get rid of? Okay? So please have those written down, highlight them, commit them to memory, like nails scratching the numbers on the back of your closet door, kind of crazy person style. Like, know the cheaters. You know that's on YouTube, right? You just screenshot it on there instead of like getting Dawson's head in the back of your picture.
Yeah.
Okay. So, all right. The last part of this section was Descartes' rule of signs. So we have the rational root theorem. It says, if I have rational zeros, meaning they can be written as a fraction, so they work nicely in synthetic division. If I got rational zeros, then they have to be one of these numbers. That was all the factors of my constant over all the factors of my leading coefficient. You guys were cool with that. What that does is it takes the infinite possibility of numbers to try and cuts it down to these 16, these 24. That's still a lot of guessing and checking, but it's better than the alternative of just hope you feel lucky. Now we actually feel lucky because the 21st century exists, whatever state it may be in. Descartes' rule of signs is another one of those that helps you narrow down the possibilities. Shut your holes. Descartes' rule of signs. I know, ew, lots of words. Bunch of polysyllabolic words. Okay. The number of positive real roots is either equal to the number of sign changes between consecutive coefficients, or less that by an even number. Huh? So instead, how many real zeros does this have?
Wait, no.
Three.
Real zeros, meaning it hits the x-axis. 3 places. How many are positive? How many are negative?
Two positive, one negative.
Okay. What about now?
It looks like two.
One or two, it depends on.
Because I don't know if that one's touching.
I will say that it hits the x-axis at that point.
Two.
Oh, it's like
Because it doesn't go.
it's the real end.
Still 3.
Because it starts and it stops.
Remember what we learned about behavior of zeros?
It's a quadratic one.
It's acting like a quadratic at that spot. So that 0 happens twice. Remember? Goes through like a line, happens once. Bounces off like a quadratic, happens twice. Remember our multiplicity stuff with our graphs? Okay. So still 3 real zeros. Still 2 positive real zeros. They were just repeated. And then I do this. 1 real zero. How many positive real zeros?
0.
How did I go from 2 down to 0 that quickly? Why does it occur in a pair like that? Let's try again. What if I had a You know what? Even better. How many real zeros does it have?
1, 2, 3, 4, 5.
Okay. How many real zeros does it have?
Is that one? No. 1, 2, 3, 4.
Remember?
4, 5.
It's quadratic. You said 5.
1, 2, 3, 4, 5. Okay. Now how
I
many?
said no. Because I was just saying
3.
3.
How many?
3.
How many?
1.
Why did it go from 5 to 3 to 1? Again, going down in pairs.
Because it's
Quadratic count for 2.
Yeah.
Okay, but why was it reducing in pairs? Why? Okay, how about this? If I have 5 real zeros and then I went to 3 real zeros, where'd the other 2 zeros go?
below.
Imaginary. The 5 real zeros became 3 real zeros, became 1 real zero, because the other ones are imaginary. And whenever I have an imaginary zero, they occur in conjugate pairs because of the plus or minus when I solve for them. That means what I'm about to do with Descartes' rule of signs, I take whatever my answer is and I have to keep dropping it by pairs. Because this is possible real zeros. And the possible number can keep going down in pairs because of my imaginary zeros. They talk about counting sign changes and then less that by an even number. That's the go down in twos. Descartes' rule of signs says, take your polynomial and shove a positive x in there. When I put a positive x in here and a positive x in here, my signs are going to be positive x cubed, a positive x squared, and then minus that, so negative x squared, plus 1. Look at the signs. How many times did the signs change? Maybe it would help if I wrote positive, negative, positive. How many times did the sign change?
3 times. No. 0. Twice.
Change from plus to minus. From minus.
1, 2. Literally, the signs. The signs change twice. Since I put a positive x squared in there, and my signs changed twice, that means there are 2 possible positive real zeros. You count the sign changes. That's it. But because imaginary zeros occur in pairs, it could have been 2 positive real zeros, or drop it down by 2. Or 0. They can go down in pairs. Just like we went from 5 to 3 to 1. So for that graph I had put up here just talking about it, I would have said it has 5 or 3 or 1 possible real zeros. You go down in pairs until you can't go into negative. So that might be 1, it might be 0. I don't know. I do the same thing for my negative real zeros. I'm going to say f of a negative x to find my possible negative real zeros. I put a negative in here. I put a negative in here. Getting a negative x cubed. Negative x squared is a positive x squared minus that, so minus x squared. And if I were to look at only my sign changes, that's negative, negative, positive. So it only changed one time. From here to here. So I say there's one possible negative real zero. Because I put in a negative x. There's a proof for it. Right now I'm just going to say, believe it. Okay? If you believe in math. Okay? Now, this one, I went down in a pair. Why will I not be able to go down in a pair from here? Because it goes to negative 1. You can't have a negative number of a thing. I can't say Rylan will now have negative number of lunches for the rest of the year. What's he going to do? Like, and then like regurgitate his old lunches? Like, it doesn't happen. Okay? That'd just be weird. Unless you're feeding birds. Okay? Why would this help me? If I take rational root theorem and I say, here's all the possible numbers I could try in synthetic division, and then I rational root theorem and say, I'm only going to try these 16 numbers. How would this help me? Because there could have been 0 positive numbers, right? 2 or 0 positive real zeros. So that means I could try all the positive numbers and theoretically none of them work. But 1 possible negative real zero. There has to be a real zero that is negative. So these 16 numbers, I'm going to start with the negatives. And when I find it, I know I don't have to try any more negatives. Because I found the one negative that was possible. It helps you to narrow down your choices. Now, we're just going to gaze into our crystal ball and see what it is. But boy, do they love Descartes' rule of theorem or rule of signs on an ACT. They love throwing this on there. I want to make sure that we got it down solid.
So it says negative parentheses x or negative x squared. So would that be a positive x squared?
But I'm subtracting it, right?
Okay, so it's just
Subtracting a positive x squared.
Wait.
Okay, this is a negative 1 times a negative x times a negative x.
So that's a positive x. Oh. Okay.
Because I'm subtracting it. Yep, okay. Now, please tell me you know what happens with an odd or an even number of negatives. If I have an odd number of negatives, what is the number? Ouch. Okay, I have a positive 5 here. I'm going to multiply it by a negative 1. It is now negative. I'm going to multiply it by a negative 1. It's now positive. I'm going to multiply it by a negative 1. I'm going to multiply it by a negative 1. If I have an odd number of negatives, what is my answer? Negative. If I have an even number, positive. Which means I don't have to show all this work. Instead, I can say f of x is just this, right? Because if I put a positive x in here, it ain't going to change it. Positive times positive times positive. If I put a positive x in here, it's not going to change it. So minus that thing. I can't put anything in here because it's a constant. Oh, hey, look. 2 sign changes. If I put in a negative x, will this stay positive or will it change? It will change. If I put a negative x in here, okay, Alistair, go sit over there. If I put a negative x in there, because there's an even number of them, will it change? Negative times negative is positive. If I subtract the positive, it is a negative number. And then constants don't change. Oh, hey, look, there was one sign change. It's not a difficult concept that x to the odd changes sign and x to the even stays the same. Okay? I don't have to do all the work if I just understand how exponents work. Okay? If I'm plugging in a negative x, it's going to do one of those two things. Either it's an odd and it'll change, or it's an even and it won't. Okay? Roger that. You do not have to overkill these. You don't have to show all the extra work. Okay. So, this one. I'll run through this one. I'm going to let you do a different one. If I say f of a positive x, none of this changes. You keep it the way it is. So I'll have a positive, negative, positive, negative. How many sign changes were there? Three sign changes. So this means there are three down in pairs, not zero, or one possible positive real zeros. Down in pairs. We went from 2 to 0, so I'll go from 3 to 1. Always down in pairs. If I plug in a negative x, this is even. Will it stay or change? Stays. This is odd. Will it stay or change? This is even. Stay or change? That's a constant. How many sign changes? That's it. Okay? Yes, ma'am.
So if it was like 6 possible real zeros, would it be 6, 4, and 2, and 0?
Uh-huh. You keep going all the way. Say I had 10 sign changes. I gave you a degree 11 polynomial, and all of them alternated. You had 10 sign changes. That means there would be 10, or 8, or 6, or 4, or 2, or 0 possible real zeros. I'm not going to do that to you, okay? I've never seen these problems go past 6, I think. And that's just kind of proving a point. So, I would like you to do these two at the bottom. Those are the ones you will do.
Oh, that's funny. Ryan did that, right?
Oh, you,
Yeah.
right, margin on the side, by your hole punch. These ones aren't big. You're just writing a couple of signs. To be perfectly fair, I know that there's not enough space on there. I first made these notes about 6-7 years ago.
This problem.
Like, I haven't changed my notes, and I wasn't about to update them this year because we're getting new textbooks next year. So I know there's not enough room on there. That is my fault for not updating it. I just didn't want to.
I put it down. Two or pass negative real number 0. What? I got you.
Only odds change.
With 5
What about? I thought constants stayed the same.
Yeah, it's a positive 5x, or positive
So the
5.
negative x is to the 1, so that's why it changes.
Well, yeah, because if I throw a negative in here, minus a negative x, plus. Okay. Okay. Watch your sign changes. 1, 1, 2. Are we getting our whole, is it going to be positive or negative thing? Okay. If it's odd, it'll change. If it's even, it won't. When I put in a negative x. When I put in a positive x, it just is what it is right now. Yes, way. 2 or 0. Possible, positive, real zeros. What do I do with that very last one? When there were no sign changes. There are no possible negative real zeros. Which meant if I did my rational root theorem, I would just not try any of my negative numbers because I know it's not even possible. Okay? Before the advent of technology, people had to do a lot more work in order to get this stuff done. There's a reason why a good number of your parents never went past Algebra 2. There's a good reason a good chunk of them probably never went past geometry. Okay? because 20, 25 years ago, graphing calculators were just starting to become a thing in every classroom. Your grandparents? No way. Like, the calculator on a Lucky Charms watch can do more than they had. Okay? Do they still put toys in cereal? I don't know. Sometimes?
I'm sad.
That was the thing. Like, you wanted to get the Kellogg's versus General Mills. Like, they had different kinds of toys. I wanted Fruit Loops because it had the cool stuff. If Mom went, oh, those didn't even come out until I was in high school. And we weren't allowed to get it because it's just candy in a bowl. Why would you have that for breakfast? Exactly. Like, Mom, you know I'm going to hit up the gas station on the way to school and just grab a 2-liter of Mountain Dew, right? All right. Fundamental theorem of algebra. Sounds pretty fancy. It's got an awful lot of words on there. I want you to read the box at the bottom. If a polynomial has degree n is greater than or equal to 1, it has n roots. That's it. That's the fundamental theorem of algebra. Yes, we did. Now we just have it in official wordology. Okay. Fundamental theorem of algebra says if I got a quartic, I got 4 zeros. If I got a cubic, I got 3 zeros. If I got a quintic, I got 5 zeros. They might be real. They might be imaginary. They might be rational. They might be irrational. But that's how many of them I will have. Total. So we come full circle. We are finally there. Here is a polynomial that if I had shown you this a month ago, you would have messed your huggies. Solve. Maybe some of us are messing our huggies right now. Okay? Now, what they want us to do is get your rational root theorem going. All the factors of 4 over all the factors of 1. Use Descartes' law of signs to determine how many positive and negatives you have possible. Whittle it down, synthetic division, until you find the ones that work. We can speed run that process by guessing really well. So I'm going to start writing this in synthetic division, and one of you is going to guess a number, and you're going to guess really well. Okay. Jaden feels very good about -2. Man, Jaden's good. Just happened to guess it right out the gate. Good job. And we talked about this the other day. Instead of just repeatedly trying the number, does it work? Trying the number, does it work? What I want to do now is I want to keep doing synthetic division in a chain. I took a quintic and I found one of the factors. What am I at now? I took degree 5, I divided it by x to the first. Not quadratic, quartic, degree 4. So, find another one. We feel lucky about 1. 1 by 1 is 1. is negative 2 is negative 2 is 1 is 1 is negative 2 is negative 2 is skadoosh. Man, we're really good at this guessing game. You must have all done the rational root theorem and Descartes' law of signs in your head. You're so good.
Thanks.
Man, y'all are good. What else are we feeling lucky about? A 2? Okay. I'll just try. 1, 2, 0, 0, 1, 2, 0. Look at us be all good and stuff. But then we run into the problem. There's no more real zeros. Good thing we learned about imaginary roots. I took a quintic and I took it down 1, 2, 3 degrees. What is this? Quadratic. I'm down to degree 2. So if this is x squared, no x, plus 1, what happens when I set that equal to 0? I get my 2 imaginary zeros. And you are never going to get to orange if you don't do the synthetic division in a chain like this. Okay? Now imagine if you were doing this by long division. Quintic divided by linear. I got my quartic. Set up another problem. Quartic divided by linear. Get a cubic. Set up another problem. Do you really want to go through that much space, or just there I am. And now I will say my solutions, x is 1 plus or minus 2 plus or minus I. I can even cheat in how I write it. I can combine them with plus or minus. I have 5 roots up there. Okay. Now this is how the majority of you are going to do it. I know a good chunk of you are coming on to pre-calc or college algebra. So I'm going to show you that you can also do this by factoring. If you are coming up to pre-calc, you're going to want to write this down because I'm going to show you both. This is something that our Algebra 2 textbooks do not emphasize nearly enough. Okay? I look for quadratic form. The quadratic form that I see is x to the 5th minus 3x to the 3rd minus 4x. See, it's this one, this one, this one. And this one, this one, this one. Minus x to the 4th plus 3x squared plus 4x. You see how all I did was rearrange the numbers. Okay? That's all I did. Why would I do that? Because now, this part, what does purple have in common? What? Oh, yeah, it is.
Nice, Brooke.
All right, you got me. What does purple all have in common right now? They're all odd x's, which means I can take at least one x out. That's 2. There we go. What do all the blue stuff have in common? Even exponents. I'm going to take a negative 1 out right now, just so I can do this. Look at what they have in common. Quartic. So if I take that quartic out, I have x to the fourth minus 3x squared minus 4 times x minus 1. This is in quadratic form. Words are hard. I can factor it just like a quadratic. What factors -4 add up to -3? Yep. So x squared minus 4, x squared plus 1. Those are now difference of squares and sum of squares. I know how to deal with those. Difference of squares is x plus the root, x minus the root. Sum of squares, what's different? An I. X plus the root, but it's an I. X minus the root, but it's an I. And then x minus 1 at the end. Take a look at your answer now. X is -2, +2, -I, +I, 1. You can do this by factoring. The reason I bring this up is because A, you should be able to. B, I'll have kids that go on after pre-calc, and if I don't emphasize this enough, they go on to calculus, they'll maybe do a dual credit calc class, or they'll do a math competition, knowledge bowl, that kind of stuff, and this comes up and they just have no idea because they never saw it. I want to at least show you. This is just factoring by grouping. I can rearrange things so that I can group stuff together that works for me. You don't have to. We're all cool with synthetic division until you hit quadratic. Use it. Okay? All right. What degree is it? How many zeros am I going to have? 4. Find them all. I don't care how you get there. Synthetic division, factoring. Maybe you do rational root theorem. Maybe you gaze into the crystal ball and commune with the spirit world. As long as you got the work to back it up, I don't care.
I got it, don't worry.
Look into your ball or whatever it's called.
I'm doing that actually.
Let's put some more descriptors on there because otherwise I don't really want Rylan looking at any balls. Might get a little awkward up in the front row.
Yep, it's already up there. I'm breaking my Yep. 32. Two. You do that one first. Okay. Is that we can do it. Oh. You're right, good job, Ron. So 2 plus 4 is what the yo. Don't worry about it. You can go ourselves. Oh, not that. No negative. Hey, look, we have 4 answers.
No, we can't do that.
One. No. I don't want to do that. Do that, Bob.
I did it by factoring.
Oh my gosh, Caden. That's a brownie point. Come on. You can't be.
This is an advanced form of factoring that I have not seen in the Algebra 2 or pre-calc books. We, the last early out we had, math teachers, we were actually talking about this. And we started comparing notes because we got 3 different teachers all doing Algebra 2. And we don't see this in the Algebra 2 textbooks. We don't even know that there's an actual algorithm to do this. Like, none of us knew what it was. Split this. Remember our AC method? We always took our B term and split it. We'd do A times C, what factors that add up to B, and we'd split our B term, right? I know how to do that because I can run the numbers in my head quick and I know what's going to work out. I don't really know how to explain it other than I guess and check 16 combinations in my head and this is the one that works. And I started asking the other math teachers about this and they all said the same thing, like, I've never seen that in a book.
-5, -0.
We don't, collectively, 5 math teachers could not tell you how do I know to do that.
You got the 0 from right there.
I know, but
You put the 0.
never mind.
What you are doing, I just wanted to show you, it is possible, but this right here, that's next level. I have never seen in a book someone actually describe how you do this and why. So what you're going to do, no, just don't worry about it. I'm going to write out 1, 2, negative 13, 10, careful, 0. Why do I need that? Placeholders. Because one of my zeros happens to be 0. Then I keep going. Okay. Then what else do you feel lucky about?
-5, 2,
1, -5, -3, 15, 2, -10, 0. We also feel lucky about 1. 1. And we also feel lucky about 2. That's a 1. Yeah. Okay. X is 0, 1, 2, negative 5. Would you prefer to do it this way instead of factoring?
Yes.
Yes.
I like the
If you want to go on past calc, if you know you're headed into a STEM field, you got to practice the other way too. Okay? Now, I will teach you the cheater way past it. Ready? Ready for this? You're all cool with this, right?
Yeah, sure.
Yeah.
Look, I factored it.
Nice. Wait, what?
Because if you know the zeros, don't you know the linear factors?
Yep.
Ta-da!
So you don't need to
Now, you do actually, if I say solve it by factoring, you do actually have to do the factoring part. But if you just want the factored answer, you can do it this way and then reverse engineer what the factors are. Okay? Save yourself some time. It's sneaky, sneaky. So, I want you to do it again, but this time, things are going to get a little imaginary.
Oh.
You notice the last two, they were kind of nice zeros. I would like you to gaze into your crystal ball and tell me what numbers you feel lucky about. 1.
Oh, crystal ball. Sorry.
It's going to bother me if the colors aren't right.
That's not normal. Why?
What do you feel lucky about? And then you said positive 3? What factors? Okay, this is a quartic by 1 degree, by 2 degrees. Now I'm at a quadratic. This is now x squared plus x plus 2. I don't know any factors of 2 that add up to 1.
Neither.
So separate. What factors of 2 add up to 1? Well, it doesn't work. So I need the quadratic formula or complete the square, whatever your jam is. Oh, 7 quarters. You haven't even written out quadratic formula yet. I'm already done.
I couldn't see the board.
Whether you do quadratic formula or complete the square, I don't care. I personally prefer complete the square. That's my jam. Doesn't have to be your jam. You can solve, now that we know what's what, you can solve every single polynomial by look at your screen, synthetic division until you hit quadratic town, quadratic formula. Okay? Every quadratic, or every polynomial that we run across right now, you can deal with those two steps. What you want to be careful about, I did this to get those two imaginary solutions. Where's my other answers? Okay. Make sure if you're going to write your solution, you write your whole solution. Okay. You're not going to get down to that quadratic. You're not going to get to your imaginary zeros if you don't know how to do all the other work that came before it. You're never going to get your imaginary zeros if you don't know what an imaginary number is. You think that's bad? Try teaching a pre-calc class like that. Because guess who had the hiccups today? That was fun. Go ahead, check it out. It's on YouTube. Okay. You want to make sure to use inverse trig function like that. Yeah, it was pretty bad. So, start to finish. Can you do it on your own?
Oh, it's right here. Got no room to do this.
Yeah, we got this little corner.
Do it off to the side of the other one. That only took out part of the page. You just did it right smack in the middle.
Well, I just did it right below it. And that goes from left to right.
Holy sus.
No, not this. So we had to sit down. No. 5, 4, 3, 2, 1. We're not doing that. Here, be cool. Oh, I didn't realize. So you don't even to do this stuff. This stuff. Yeah, I did. Oh, we did it.
Yeah.
And then do it. Anyway. Mr. Soul.
Hey.
I don't know if I typed this right.
I think you did.
Because this does not look very, like... Oh, I...
It does. It's right.
Okay.
Those are different questions, part A and B.
Sorry.
But it's still.
Part A and part B are two different equations.
Yeah.
The graph on your screen should not look like the graph to the right of your problem. Okay.
Not even close. That part.
That don't work. What else works? My mental math ain't working right now. -1? Okay, so 1, 1, 3, negative 3. Factors a positive 6, add up to negative 1. That ain't happening. So, uh, 8, 8, negative 24, negative 23. No, because I add it to the other side. Okay. There's your fundamental theorem of algebra. I can now solve them all. Okay. 1, come work with me. We'll do them together. 2, less of this will alleviate that. All right. No, just that. We're there.